Today's topic is translating. This is section 11, so grab your notes and get ready to go with this one. What we're going to look at today is translating functions. So when you think of translating in a foreign language, you're converting from one language to another. When we translate functions or equations, we're going to describe what happened when we went from one equation to the other. So we're going to start out here by graphing and looking at some of the changes. So first example here, graph y equals x. Now this is a pretty common function, and what we are looking at here, I'm going to write the slope-intercept form again at the top. So I want you to write it on yours, y equals mx plus b. So remember, we need to identify m and b. So I do have a slope and a y-intercept in the equation y equals x. My slope, my m, is equal to the value in front of the x, which is 1. And remember, I want a fraction, so write that as 1 over 1. The y-intercept. Now you might say, well, there's no number there. Well, exactly. So the value that represents nothing is 0. So we are going to graph the equation y equals x. So remember, start out on the y-intercept at 0, and we're going to go up 1 over 1. So I'm going to go like that, up 1 over 1, up 1 over 1, and then you can remember, go back to the original starting point and go down and over. Okay, so draw yourself your line, and there's y equals x. So if you can grab another color, like a pen or something else, go ahead and do that. So on the same coordinate plane, we're going to graph this equation y equals x minus 5. So let's identify the m. The m is 1 over 1, and the b is negative 5. So start with the negative 5, so I'm going to go down 5. So I'm at 1, 2, 3, 4, 5 right there. And then I'm going to rise up 1 over 1, up 1 over 1. So something like that. I'm going to go back and go the opposite direction. And there's my line. Okay, let's describe the differences between the graphs. Well, let me actually go back here. This is, of course, you can go by my colors. I was going to number them 1 and 2. But the differences between the graphs might be, one thing is where they cross the y-axis. So that would be one difference. They cross, oops, that's not very good writing. Let's try that one more time. They cross the y-axis. Get my pen back. Cross y-axis at different locations. At different locations. Okay, cross y-axis at different locations. Okay, what about the differences in the equations? So think about when a line crosses the y-axis, what is that? Well, that is my y-intercept. That is my b. So look here at the two values of b. Well, the differences in the equation is I have a negative 5 for b and, excuse me, a 0 for b. So it has different, and I'm just going to abbreviate, different, and I'm going to put in parentheses b's. Different y-intercepts. So what about them stayed the same? Well, hopefully you're looking at that saying, these two lines are parallel. And remember, the reason they're parallel, let's look at their slopes. If they have the same slope, they are parallel. So what stayed the same? Slope. And I'm going to put an arrow here, parallel. Okay. And then we already addressed what's different. Slope, parallel, I'm going to say here same. Same slope is really what I should have said, which makes parallel lines. And then what's different here, I'm just going to point here, different y-intercepts. Okay, so that's one way to describe differences and similarities, is to look at the graph and see what it looks like. Okay, let's move on to example 2. We are going to graph y equals negative 2x plus 1, and then also y equals negative 2x plus 5. So remember, when we graph, we identify our m and b. So m is negative 2 over 1. B is 1. So begin with your B right there. Negative 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So there's my first line. Switching colors here, y equals negative 2x plus 5. M is negative 2 over 1. B is 5. So begin with the 5. So go up 5. 1, 2, 3, 4, 5. Looks like it's about right here. And then down 2 over 1. So repeat that a couple times until you see your line. And then draw your line. Okay, describe the differences between the graphs. Well, the graphs, they have different y-intercepts. So I'm going to say here, different y-intercepts. Well, the differences in the equations, it's really kind of the same thing. Different, and I'm going to use the term b's because that's really just the y-intercept. What stayed the same? Well, they have the same slope. Same slope. Which means they're parallel. Because remember, when the slopes are the same, that keeps the angle the same, which will drive parallel. Now, one thing to look at, I want to point out here, is if I look at, I'm going to circle here, look at the y-intercepts right there. So you could say that our line moved up 4 units, right? If you count, we've got 1, 2, 3, 4. So another thing I'm going to add here is line went up 4 units. So it was translated 4 units. It went from a 1 up to a 5. So if you kind of go back and look at the equations with the b's, I can look at the 1 and the 5 and kind of make that determination without graphing, which is eventually where we're going to go. So that would be an increase, you could say, of positive 4, going up 4. Okay, let's move on to, and we are going to look at some information and hopefully not have to look at a graph for everything. So I'm going to add some information here at the top. I'll move my page down a little bit. So what I want to write at the top is when two equations have the same slope but different y-intercepts, it's called a translation. So when two equations have the same slope, and then in parentheses I'm going to put m because that's what my slope is. When two equations have the same slope but different y-intercepts, and I'm just going to abbreviate different. If you want to write it out, that's fine. Different y-intercepts, and in parentheses b, when they have the same slope and different y-intercepts, it's called a translation. It's called a translation. Translation. So it was translated a certain number of units. So here are my two equations I worked with earlier. I've got same slope, but then the different y-intercepts. So, let me back up. I don't want to compare those two. Let me erase that. Let's look left to right. So I've got here same slope, but then I had a y-intercept of 0 and a y-intercept of -5. So it went down 5 units. Second one, I had same slope, and then it went from a 1 to a 5. So it was translated positively 4 units. Okay, so let's look at another one now. We're going to describe the translation. So your questions will be worded like this, where it says to describe the translation. So I'm going to, again, just graph both lines and look at them. So number 1, graph y equals 2x. So my m is equal to 2 over 1. My b is a 0. So 0 would be right here. And then up 2 over 1. about right there, up 2 over 1. And so connect your line. Okay, now let's graph the second equation. M is equal to 2 over 1. B this time is -6, so go down 6. 1, 2, 3, 4, 5, 6. And then up 2 over 1, up 2 over 1. See if I can draw a straight line. There's my line. Describe the translation from 1 to 2. So you are looking at, of course, my red line is my first line. I'm looking at, since my slopes are parallel, I'm going to go back here to the top. When two equations have the same slope, which these do, but different y-intercepts, it's called a translation. So I am describing the translation, and I started here and I moved down. And so when I describe it, I talk about how many units it moved down. So I can count. It moved down 1, 2, 3, 4, 5, 6. So I'm going to say moves down. I want to give a direction. 6 units. Now, I also want to point out, if we looked at just the equations, let's say I didn't do the graph. I could take my original y-intercept, which is a 0, and subtract subtract the other one, which would be down, or -6. So that would actually end up being 6. Now I need to know it's going down because of my negative, but that's telling me the direction. Okay, I want you to do the next one. Okay, so why don't you stop here? I want you to do 4. If you can, you might pause it, at least graph the equation, and then come on back and we'll write the equation. So pause right now and try this one on your own. Okay, on this equation, or on this graph, identify M and B. M equals 1/2, B is 4. So I'm going to be 1, 2, 3, 4 units. And I'm going to go up 1 over 2, up 1 over 2. There's my line. Translate the graph 8 units down. So I can actually count. You want to be looking at your y-intercept here. So I want to count. It's going to go down 8 units. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So right here is where the graph will land. And so I need to, if I'm translating, I want same slope. So I'm going to start at the green dot and go up 1 over 2. I'm going to do the same slope again. Okay, and I can graph it. But if I'm going down 8 units, which I can think of as -8, my new equation will still be y equals 1/2 x, but my new y-intercept is -4. Okay, and so you could actually think about taking the +4. I went down 8 units, and when I do 4 minus 8, I get -4, which represents that new y-intercept. Okay, let's example. Okay, now we have a few sort of problem solving, just continuing to work with, slope and y-intercept. If the slope of y equals 3x plus 5 is changed to its negative reciprocal, but everything else stays the same, what's the new equation? Well, I'm going to change my slope, first of all, the number 3, to its negative reciprocal. So 3 is positive, my new number will be negative, and the reciprocal of 3 over 1 is 1/3. So my new equation will be y equals -1/3 x, and everything else stays the same. So it would say plus 5. So I'm just kind of processing through what negative reciprocal is. Next problem, compare the slope and y-intercept in the two equations. Well, I don't know what the slope and y-intercept is. I need to solve for y. So go through that process, rewrite it in slope-intercept form. So I'm going to take away 3x. That gives me -6y equals -3x plus 36. I'm going to divide by -6, divide by -6, divide by -6. And so let me zoom in here a little bit. So what I'm going to get here, straighten that out, I'm going to get y equals -3 over -6 reduces to a +1/2 plus 6. second equation, I'm going to this time add 2x. So I get 4y equals 2x minus 16. Divide everything by 4. So when I do that, 2 divided by 4 is a half, and then minus or negative 4. Compare the slope and the y-intercept. Well, slopes are both 1/2. Okay, so I've got same slope. And then compare the y-intercepts, a positive 6, a negative 4. So we don't need to be super elaborate here. All I really want you to recognize is they have different y-intercepts. And that's it. Okay, we don't really need to talk about a whole lot about it. Now, if we want to add to that, we could say that it went, I guess you could say, down by 2. You could describe what happened. But I just want you to recognize that they are actually different. Okay, let's finish up here reviewing how to graph equations with one variable. So graph the equation x equals 4. Remember, the only requirement in this equation is that x must always be 4. So add 4 all the way down in your table. Y can be anything. So if I were to graph that, I would have 4, 1, 2, 3, 4, 1, which looks like it's about right here, 4, 2, and 4, 3. So that is going to give me this completely vertical line. On the opposite side, on the next equation, if y equals negative 8, the only requirement is negative 8, always on the y. And then the x can be whatever I want. So let's graph 1, negative 8 would be about right there. Oops, that's negative 1. Let me back up. Don't do that. 1 on the positive side, 1, negative 8 would be about right here. 2, negative 8, 3, negative 8. So my equation is completely vertical. So always make that table, but to add to that, all vertical lines will always be in the form of x equals some sort of number. And then to add to that, your slope is always undefined. You cannot define a vertical line slope. Horizontal lines will always be the equation y equals some kind of a number, and your slope is always 0. Okay, so that wraps up translating and just gives us a little more review on graphing. So if you have any questions, please ask those in class or talk to one of your classmates.